I know things get in the way, but you always know I'm starting the class with questions, right? I might not always record them, but I'll try and make sure I'm always recording when I start teaching new material. So find the critical values. So what do we got? X minus 3 equals 0. So x equals 3, right? 2x minus 1 equals 0. So x is 1/2. Is that okay? Is that okay with everybody? So those are my critical values. I want to create rows based on factors and columns based on critical values, right? So rows and columns based on factors and criticals. So I should be thinking about the domain. Of course, everything except for 1/2 is in the domain, right? So I'm kind of thinking of this number line like on my desk in second grade. You remember that one? I can still see Molly Peer right across from me, but I remember my number line on the desk. And so I have a 3 and I have a 1/2. The thing about the 1/2 is I like to think about it as empty. Why? Because I can't use it, right? I can't put 1/2 into this function. It will make me divide by 0, right? You with me? So that's why it's got the open, right? Open parenthesis like. My factors are x minus 3, 2x minus 1, and a combination of them as f of x. So you can see my factors are creating rows. Hey, right? My factors are creating rows. My criticals are creating columns. And I know I go all the way to minus infinity and infinity here. That's not always the case, but in this case it is. I'm thinking about the domain. It's everything but minus 1/2. And now I want to use test values. What are test values? So first of all, it helps a lot. All semester, please, I'm telling you, all semester. Graph these things. When I give you a function and you don't know what it looks like, graph it. So what do I have? X minus 3, is that right? Over 2x minus 1. So there's my graph, right? So now I can definitely see it's going all the way to the left and all the way to the right, right? So I want to now create test values like 0, 1, 5, anything left of, right of, and in between my criticals. And we're going to do this in Calc 1, we're going to do it pre-Calc, we're going to do it in Calc 1, we're going to do it in Calc 2. Now I'm just asking, what do I get sign-wise when I plug 0 into each factor? Well, when I plug it into the first one, I get a -3, right? But all I care about is negative. And when I plug it in the second one, I get also a -1. All I care about is negative. Because negative divided by negative is positive. Look at my graph left of that -1/2. It's above the x-axis. It's up in the air. It's positive. And you see f of x I have is positive, right? When I plug the 1 in, I get a negative and a positive, so I get a negative. So between -1/2 and 3, my graph should be underground. Do you see it that way? Between 1/2 and 3, the purple graph is underneath the x-axis. Eli, yes, this clicking? Yep. And then finally, and so look, I don't even need the sign table. The sign table is just me faking out the instructor that I know what the hell is going on. I can see what I should get from the graph. right? And when I plug into 5, of course, I get positive and positive, and when I divide those, I get a positive, right? So I might ask something like, f of x is greater than 0 when x belongs to minus infinity to 1/2 union 3 to infinity. And we'll talk more about that today. But if you can see, my critical, I got my minus infinity to 1/2, right? I can test anywhere in there, and I'm going to get a positive. The function is greater than 0 in there, so I made a mistake. And it's also greater than 0 between 3 and infinity, but not including 3. At 3, it's 0, right? So at 3, it's 0, so I got to change that. Does that make sense? The square bracket means I can include it. The open bracket means it can't. See that? Exactly. And remember, my whole function is this divided by this. So negative divided by negative divided by. Yep, that's the key. And typically, in pre-cal, we do them this way. In Calc 1, we make it much easier. I want you to understand this way first before I strip everything off of this for Calc 1. And we're going to do more of those today. Nice. Johanse? You moved? You want to move there? That's fine with me if you do. No, I don't mind. I don't mind. If that's where you want to be, that's fine. Nice. Jorge, Francisco, Hassan, Emmanuel, and Winkuni, yes. Jason? Yes. You just got pushed forward, but you can stay there. That's fine with me, okay? Thanks. Leandro's there. Nice. Tivon's not here yet, right? Tivon's not here. Brian, is that you? I thought you said you... Did you say you weren't coming in today? No. Yeah. You did, but you're okay? Yeah. Okay, good. Chris is not here yet, and Sina's not here yet. Everyone else is... Oh, Benjamin, I'm sorry. Were you not here last class? No, I assigned seats last week, and that's fine. Is Francisco here though? No. All right, Ben, you can move there. We'll force Francisco to move somewhere else. No problem. There's lots of reasons to miss class that are out of your control. You just want to make sure you're keeping up. Watch the videos, right? So why don't I do another one like I'm going to put on the quiz, okay? Hey, Tavon or Francisco? Yes, nice. Thank you. So, I mean, this one's not bad it's not on the quiz, but it's not a bad one for the test, okay? Like a problem like this. But you're going to see in 3.5 today, I'm going to give more difficult sign tables. So we'll just wait for one of those, I think. Let me do one that's like on the quiz. So I want to show I have a mother function for x squared, and the typical problem is the table for this one is, right, I probably want on my formula sheet. If you see every time I did it, right, I did from -2 to 2, and I'm just squaring everything. So I get 4, 1, 0, 1, and 4. Is that clear with everybody? So the tables for the mother functions, I don't think you have to have them on your formula sheet, but you can if you feel like you might get nervous and forget, whatever. But I want to show that f of x equals, let's say, 3x squared minus 12 minus 1 is a transformation of x squared. And I want you to give me the new table. Does that make sense? So I'm going to use that mother to daughter to granddaughter idea, or just mother to granddaughter right away is fine with me. Okay? So, and we want to do this by completing the square. So this is 3x squared, oh, sorry, that's a 12x, minus 12x in parentheses, and then keep the constant out, right? Yes, you with me? I want to factor out what number? The leading coefficient. So I want to factor out the 3. And I get x squared minus 4x. When I do this, let's make sure I double check it. Distribute the 3 back in. Do I get 3x squared minus 12x? Yes, of course. Right? Now I find that value of k of negative 4. Yes, you with me? It's the coefficient of x. Why am I calling it k? So I can make the joke, if you see k, and so I don't confuse it with b, right? Remember, ax squared plus bx plus c, right? Trying not to confuse it with that variable that we've used before. It's the coefficient of x. It's that simple. Yep. Then I want half of k. Then I want half of k quantity squared. And I'm going to add that to the inside and subtract it on the outside. What the heck? Right? So I got k, negative 4, right? I got half of it. Squared it. I added it on the inside. Look at what I really have. I don't have a 4. I have what? 12. So I want to subtract 12 from there. Again, don't move on here until you're sure of yourself. Distribute everything and make sure it works out. Look. 3 times x squared is x squared. 3 times negative 4x is negative 12x. 3 times 4 is 12. Minus 12 is 0. Minus 1 is the minus 1. I want to make sure I've not changed anything, right? Now, that junk I have in parentheses on purpose always turns into x plus half of k quantity squared every single time. Every single time. We're doing it on purpose. Complete the square. Make a square out of it. And there is my transformation of y equals x squared. So what did I do to the x's? Did I add to or subtract to? Added to. If it's inside, it behaves inversely. So I added 2. So I got 0, 1, 2, 3, and 4. You agree? Look at all my old x values and look at my new x values. Yes, you with me? Good. What did I do to the y's first? What did I do on the outside first? Follow my drunk Aunt Sally. Please excuse my drunk Aunt Sally. MD, multiplying first. So I'm going to multiply my height by 3 and then subtract. So can you see x squared here? Can you see the mother function here? See x squared? Okay. But I shifted it over to the right. I stretched it up and then I moved it all down. So I'm going to multiply my y value by 3. What do I get? 12, and then subtract 13. Negative 1. Multiply my y value by 3. 3, subtract 13, negative 10. Multiply my y value by 3. 3 times 0 is 0, subtract 13. Multiply my y value by 3. 3, subtract 13, negative 10. Multiply my y value by 3, that's 12, subtract 13. Look at the symmetry on both graphs, right? They're both x squared functions, right? You with me? I want to go to Desmos. I want to go to Desmos on this, right? So I had one function y equals x squared. And I have my new function y equals 3 times, oh, sorry, it was 3x squared, right? 3x squared minus 12x minus 1, is that right? Do you see that the black curve, the red curve got stretched up and it's tall and skinny now? Right? The black curve is the original model function, right? You see that it moved to the right and moved down? That's all we're trying to see. Let's plot some points. Let's plot the vertex on the mother function. That was 0, 0, right? And what do we get for our middle point on this new function? 2, negative 13, right? Look, do you see that they're matching up? If you kind of see my first curve going through 0, 0, 1, 1, my second curve, I'm going to move over 2, right? I'm going to move down 13, and I'm going to stretch it by 3. Not a very good graph, but I'll try again. So I moved it over 2, down 13, and I stretched it by 3. How are we doing? Manual, no? No, what part? The table? So what depends on things? Figure in front, right? So all my x's move to the right. So I put all my x's from -2 to 0, -1 to 2 to 1, 0 to 2. Yes? Then I'm multiplying my y, so I'm multiplying by 3 to the y column and then subtracting by 13. This is inside affecting the x's only. These are outside affecting the y's only. What's nice about this is I can go into Desmos and go to the gear and do my table. So look, my table's automatically done in Desmos here for the mother function. If I go here, right, and go in my gear and hit my table, I started at 0, right? And then to 1, and you see it's generating everything for me. Then to 2, you see, generating everything for me. Of course, I probably also want to graph my completed square version. Y equals 3 times, parenthesis, x minus 2, close parenthesis, quantity squared, minus 13, right? And notice, and let me change my color here on this second curve. Oops, damn it, undo, undo, ooh, nice. Notice when I hide the orange, whoops. No, I got it. When I hide the orange, you see the other curve shows. It's exactly the same curve. So I know I completed the square right. Emmanuel, this any better now? Yeah? Nice. So you're going to have one like that on the quiz. And the other one is difference quotient. So I'm going to give you a simple polynomial, ask you to find the difference quotient, ask you to verify slopes. Yes? 2 questions. Yep, 25 minutes, 2 questions. So at 4 o'clock, I gave you the quiz. You have until the end of the class. And then that's it. And if you're done early, you go home early. That's nice. It's always at the end of class. When we take our tests, it's always right at the beginning of class. So you'll have the whole class period to take the test, right? Oh, wait, that's not true. What am I going to do? I'm going to give you 2 hours. So you'll have from 2 to 4, and then you go home after that. Nice. Can we move on? Cool. We got really easy stuff to do today. You've done it all before. So it's just about you practicing, remembering, putting good notes onto your cheat sheet, right? So that when you're asked for any of these types of problems, you can think about it and abstract your knowledge from before. Our first test is chapter 2 and 3 only. Our second test is chapter 4 and 5 only. Our last test is trig, 6, 7, and 8, chapter 6, 7, and 8. Okay? That's the tough one. All right, here we go. New stuff. So we're talking about we're only doing 3.1 and 3.1, 3.3, and 3.5 today. And again, I put in problems there. I want you to hand me Monday. I would like them to be stapled. I'd like you to check them because you have the answers, right? Excuse me. I'm not adding anything special to them, so just do the problem as the book says, right? Excuse me. And of course, try other problems that are similar. Right? You'll see each problem is from a section of problems, and you could try any of them. So our start today is 3.1, linear functions. I've already kind of done everything in this, assuming you had Algebra 1 in 8th grade or 9th grade, right? You probably also did them in Algebra 2. Sorry for the cough. So we're going to start with our standard form, which we almost never use, ax plus by equals c. We almost never use this form. You'll see it sometimes in some textbooks, but we should be able to convert any form into any other form. Our point slope form is y equals mx plus b. You remember that one, right? Yes? Hello? You remember that, right? Yeah. And then we want to graduate. That's kind of our middle school version of it. We want to graduate to point slope form. I'm sorry. Sorry, this is not point slope form. Silly me. This is slope intercept form. M is the slope, right? And B is the y-intercept. Slope-intercept form. And our last one, y minus y1 equals m times quantity x minus x1. This is our point slope form. So I should be able to convert these from one to the next with no issue at all. I have to always be able to find the slope, right? I should always be able to find the y-intercept. I guess I should be able to find the x-intercept as well. But that's pretty much it. So, so what do I need for a line? How many points will give me a line? 2. Okay. So I need 2 points. And the 2 points will give me, let's say, x1, y1, right? That's my first point. And x sub 2, x2, y2. right? I'm just using those subscripts as counters. Yes? Using the subscripts as counters. And of course, then I get my slope from y2 minus y1 over x2 minus x1. What else could I get? So if I got 2 points, I got my slope. And then I could also need the slope in 1 point. Right? So if I get 2 points, or if I have the slope in 1 point, most of the time I'm going to be using this version. But I'd like to be able to convert it into the other version. Standard form doesn't happen often. I never ask for it. Okay? I want these other two. So let's do an example problem. Yes? Yes, we ready? So find the equation of a line right, in all three forms if x1, y1 equals 2, 5, and x2, y2 equals 3, 6. Sorry, 3, 4. I'm just making the points up. Any 2 points will get me a line. So, if I think about it, in the first form, the standard form, does it tell me what I need? No, it says ax plus by equals c. It doesn't tell me anything. That's going to be the one we get to last. In the second form, I need a slope. I don't have it, and the intercept. I don't have it. You with me? In the third one, I need 1 point. Got that, and I need a slope. So that's the secret there. I can get the slope from here. So my slope is 4 minus 5 over 3 minus 2. So negative 1 over 1. So my slope is negative 1. I can use either point as my xy, right? So my equation is y minus y1 equals m times quantity x minus x1, right? That's going on my formula sheet. I use it all the time in calculus. So this one is your new friend. So what point should we use? All right, fine, 2, 5. So y minus 5, exactly. Y minus 5 equals negative 1 times x minus 2. Right? Does everyone see where things are coming from? And this one is where I want to go to most of the time if I can. This equation. Let's turn it into the slope intercept. I get minus x plus 2, right? Distributing the negative 1. Don't let me go too fast. And now add 5. So this one is my point slope. This is my slope intercept. And if I just move the x over to the left, I've got my standard. Stupid. How we doing there? It's not bad, right? Sorry, just 1 second. Okay. All right, let's look at a problem or two. So that's everything about it. Okay, so what do we know, right? What do we know? The b value is 7. 1, 2, 3, 4, 5, 6, 7. Yes? The b value, mx plus b. That's where it crosses the y-axis. And my slope is negative 1, so I'm going to go down 1 over 1. Down 1 over 1. And there's my line. I'd like to think of that y equals mx plus b is where do I begin and how do I move? Where do I begin and how do I move? Start on 7, down 1 over 1, down 1 over 1, right? For a negative 1, the slope of negative 1. This feels like a review, am I right? Feels like you've done this in your life before, am I right? So just looking at number 13, pretty simple, right? I'm going to begin on 3 on the y-axis. I'm going to move up 2 over 1, up 2 over 1, right? Yes, you with me there? So determine the slope and the y-intercept, right? Use the slope and the intercept to graph. Determine the average rate of change, that's stupid. And whether it's increasing or decreasing, also stupid, right? So y equals 2x plus 3. So this is 3.1 number, I forget already. Thank you, number 13, 2x plus 3. Once I get it in this form, it doesn't make much sense to go to point slope form. But it certainly could make sense to go to standard form. But again, I'll never ask for it. So when I put in 0, I always get the b value. When x is 0, I get the y-intercept, I get the b value. I can quickly generate points by picking smart values of x. So 2 times 1 is 2 plus 3 is 5. And now what I'm saying is I don't need to think at all anymore. I don't need to calculate. My x's are moving by 1. My y's are moving by what? 2. Right? 3 to 5 is by 2, right? So 7, 9, 11. My x's are moving by 1. My y's are moving by 2. You see me how I'm generating that quickly? So for example, y equals 2 times negative 1 plus 3 is what? Negative 2 plus 3 is 1, right? And you see that entry on my table. So I could check any entry on my table with that. It's nice to graph that one. Of course, you have Desmos. You're going to be able to graph anything, right? And plot points on there. But it's nice to be able to graph this just by going 1, 2, 3. That's where I begin. Let me go up 2 and over 1. And there's my next point. Right? Where do I begin and how do I move? Right? So I give you a linear function, you give me the table and the graph. Simple. The rest of that instruction is ridiculous, right? What's the slope there? 2, right? Find the intercept, 3. Graph the function. What's the average rate of change? It's dumb. It's a dumb question. Let's see how we humans take really silly, simple things and make them more complicated. What's the average rate of change? 2. It's the slope. We already know average rate of change is slope, right? And then, is it increasing? left to right, right? I like to think of that the letter N doesn't fit on there. So, but if I have a line that's decreasing, right? I can see that the letter N, so this slope would be negative, right? I can see that letter N fits nicely on the line there. So this one is decreasing, negative slope, right? And when I have a positive slope, I'm increasing. Simple, yeah? Nice, Chris, you made it. Great. And nope, what's that? Who else just came in? Leandro? Sorry, Leandro? Yep. Yes, question. Homework next time. Thanks. That's fine. That's fine. Talk to me. Yvonne? Sorry, Ivan? Question in the back? What? Oh, John. Oh, you just came in. I'm sorry, John. Thank you. John, were you here? You weren't here Wednesday, right? So is that seat good for you? You want to move? Just sit there for me every time unless you want to move now. You need to move closer or anything? It's up to you. Up to you, okay? Who got a question? Jason, did you have a question? No? Anyone have a question? Anywhere, John. That one at the far end is not taken, either of those. That's great. Thanks, John. All right. So I signed problem 21 for homework. Let's take a look at don't tell me. Let's take a look at 26 here. So 26, look at my x values. How are they moving? By what number? Every time I move to the next row, what are my x values moving by? Number 26. Can we see it? The x values. So by 1, right? Yeah. What about my y values? By a half, right? I'm adding a half every time. So that is hinting at, and I don't know if you've ever done this, walked on stairs that were awkward and they didn't feel right, and the steps are different sizes. When we're walking a line, every step should feel exactly the same. The rise and the run are the same on every step. You know what I'm talking about at all? You ever walk on stairs that were like really, like I walked on the Great Wall of China, right? They're all falling apart, but the stairs are different sizes depending on where the steepness of the hill is and all of that type of thing. So this one appears to be linear. Of course, you could graph it, okay? You could graph it, and you'll know if it's linear or not. But we want to just pick random points here and get slopes, and then see if it works out. So it's not really that interesting to me to give you one that's not linear. So the one I gave you for homework is linear. But I would like to be able to do this, right, in some kind of systematic fashion here. So this is 3.1, number 26. And I gave you an XY table of -2, -1, 0, 1, and 2, and -4, -3.5, -3, -2.5, -2. I'd like to be able to check any two random points and see if I get the same slope. If I check every two random points and I get the same slope, I know it's linear, right? So let's pick these two right now. So what's my slope? -3 minus a -4 over 0 minus a -2. So I get 1/2. You with me? Right? So that's my green slope. Let's pick the blue slope here. How about this one and this one? What's my slope here? -2 minus what? A -4. So that's -2 plus 4 over 2 minus a -2. So I get 2 over 4, which is again 1/2. Every 2 random points I pick, if they're always the same slope, I know it's linear. The conversation is, are the x values always moving at the same rate? By 1 in this case. Are the y values always moving at the same rate, maybe different than the x's? By 1/2. Right? So what's my b value? You see it on the chart. -3. When x is 0, the y value that's there is the b value. So on this one, I can go right away to mx plus b form. Slope-intercept form. I could also do standard form here, right? This is -1/2 x plus y equals 3. And I'm going to multiply everything by -2. So do you first see this part? Do you see that I moved the x piece over? Right? So now I'm going to multiply it by -2. And I get x minus 2y equals -6. There's my standard form. Again, I will never ask that. Some calculus books use it. I don't know why. And then, of course, if I use my table, I can get point slope form, right? Y minus what? What do you want to do? Which point? How about that one? Y minus a -2 equals 1/2 of x minus 2, right? We okay? So in the first homework question I give you a table and I say, is it linear? If the answer is yes, and it will be yes, find me the equation of the line, right? That's simple. I'm hoping this first test is very easy for us because the second test is more difficult. The last test is very, very difficult. And of course, the final is difficult just because of the volume of the material, the amount, okay? So Sina's not here today. Ethan, Yvonne. Did Yvonne leave? Yvonne, you back there? Ivan's gone, right? Jason, did he remember his phone charger? Oh, he's still there? What? He took his phone? Oh, that's yours. I mean, attendance, I take attendance because the school tells me I have to, okay? What I notice is if you miss 4 or 5 classes, you fail the class. So just be careful, that's all. In my syllabus, it says if you miss 3 classes this semester, I can drop you from the class. But that involves me doing petty paperwork, which I'm completely annoyed by, so I never do it. I'll just let you fail. It's better for my record to have you drop the class because then my passing rate doesn't look bad. But I don't care. I don't care. I have failed in my last 2 pre-cal classes 75% of the students. That means only 5 of you would pass. Not good. Be serious. Get this done. It's not about you passing this class. It's about you being ready for calculus. And then almost all of you, wait a minute, only 1 of you, 2 of you don't need Calc 2. But Eli, we might go to Calc 2 because that's revolutions of solids, right? 3D imaging things. Rafi probably don't need Calc 2, but again, if you're doing animation in movies, maybe. But the rest of us are taking Calc 2. Yes. I don't care about this class. I care about the next class. You should see how many students of mine cannot do trig in my calc class. They're all going to fail. When I get to chapter 6, 7, and 8, you make sure you eat the book. You do everything. Right? All right. Next type of interesting problem in 3.1 is inequalities of linear. So I'm looking at oh, there he is. You okay? All right, good. So I'm looking at several of these inequalities. I like the ones with 2 lines. So in this particular case, 33 is interesting. I don't remember which one I gave you. You do though, right? You know which one I gave you. So I like the ones with 2 lines. Which one did I give you? 3.1. This one is silly. Oh, here, I think I gave you 29. Let me do 30. I gave you 29 in 3.1, right? So let me do 30, okay? So this one it's real important that we can do this Desmos and algebraically, okay? Graphically and algebraically. So 3.1, this is our last problem in 3.1 today, number 30. Your problem for homework is 29, okay? Yeah. Right, didn't I? Let me see, where did I put that? Yeah, 3.1, 23, 29. Right? All right, so this is 3.1, number 30, sorry. I have 2 functions, f of x equals 3x plus 5, and g of x is negative 2x plus 15. What's the first thing I want you to do? Graph them on Desmos. You could use your TI-83 or 84. I don't care if you do that. I think Desmos is more powerful and easier to use. So I'm going to Desmos. And I'm going to graph these 2 lines. I do like using the f of x notation because I can just plug into that often a quick way. But in this one, I don't really think it matters, but we'll still use f of x. So you should be doing this with me on Desmos right now. F of x equals 3x plus 5. And my other line, g of x equals negative 2x plus 5. It's pretty obvious where they meet, right? It's kind of obvious where they meet. They meet at the y-intercept. Yep. Y-intercepts are matching. It's obvious from the graph where they're right? Not so obvious where the easy to find. So the question this one is asking me, now that I have a picture, and I want to remember f of x is the black line, g of x is the red line, right? That's nice that it gives me color too here. So it's asking me, when does f of x equal 0? So it's just going to give me a bunch of problems. F of x equals 0, question mark. At what x, right? So what's my f of x? 3x plus 5 equals 0. Gives me what? 3x equals negative 5, or x is negative 5/3. That's the x-intercept, right? You with me? I know it's insulting. I promise you, chapter 4 will not be insulting, Brian. Say it again. Brian, one more time. It's 5. Sorry. Thank you. You know, what was I thinking of? I'm thinking of the next problem 1, and I'm writing 1/5 instead of 5. Oh, it is 15. You're right. I have it wrong. It is 15. I'm sorry. I put it in Desmos wrong, right? I like that one better anyway. All right. It didn't change my first question, though. Thank you for correcting me. Always correct me, please. My teachers used to say, I'm making a mistake on purpose, just to see if you're paying attention. For me, it's not that case. So work along with me and make sure you fix it, right? So anyway, this is my place where the black line hits the x-axis, yes? And watch what I do on Desmos. I say, okay, x is negative 5/3, right? Comma 0. And then I plot my x-intercept. Yes, you with me? I already know my y-intercept there is 0, 5, right? So I've got the x-intercept and the y-intercept for both for the black line. You could tell me the slope right away because it's written in the equation. It's 3, right? But you could check the slope, right? How do you check that slope? So I had negative 5/3, 0, and 0, 5, right? So the slope there is what? 5 minus 0 over 0 minus a negative 5/3. So I do keep, change, flip. And I get 3. Anyway, back to the problem. It says, when does f of x equal g of x? Well, it's simple, right? Just set the two equations equal to each other. The first equation is 3x plus 5. The second equation is negative 2x plus 15. Solve for x. 5x equals 10, x equals 2. Do you see how I'm solving for that quickly? I mean, I'm sorry, this is something you do, right? But 5 over is negative 10. 2x over is positive 5x, right? What's nice is I can now just check that on Desmos with this point, 2, comma, f of 2, right? I don't even need to know that height, but I can just see, is that hitting where they're matching, where they're crossing? Once I know the x value, I can just plug that x value into f or g to get the height. And what's the height look like, 11? So f of 2 is 3 times 2 plus 5, 6 plus 5, 11. Anything we do on Desmos, we'd like to be able to verify it, right? The interesting one here is when is f of x greater than g of x? So I like to think of this thing as above and below. It's asking me, when is my the function f of x above the function g of x? Or better yet, on Desmos, when is the black line above the red line? When is the black line above the red line? For what x values? So I know they meet at 2, and to the right, right? The black line is always above the red. So when x belongs to the interval 2 to infinity open, what does x belongs to closed 2 to infinity open mean? What's going to change here when I change that open endpoint to a closed endpoint? When it's open, it can't be included. When it's closed, it can be included. So what changes in my green circle? What am I putting in between f of x and g of x here? Not greater than, but greater than, equal to, right? So now I'm saying, or allow them to be at the same height, but then I want f to be higher for the rest of the way. It's kind of nice on Desmos, watch this, if I restrict f with a curly bracket, space, curly bracket, x bigger than 2, you can see, right? Now you can see the black being above, right? Cool, that's 3.1, that easy. Let's take a little break, let's come back in 6 minutes, 3:10. What's shaking? That's fine. No problem. Put your mask on for me, okay? Sorry. I don't have my glasses on, so I can't see who's got their mask on or not. Quintuni, you might, if you're talking about 420, are you talking about 420 or 430? Oh, I don't know if I'll make it all the way to 435. Yeah, you said you had to leave a little early, and our class ends at 4:35. Oh, no problem. You do what you want. You're paying me, so Or if you don't mind, you can just go out in the hallway and eat. Is that okay? I appreciate it. Four minutes, okay? A little insulting right now, huh? The material. Is that fair to say? Too easy? No? Next section, we really have done the most of the part already, which is I always say 500 milligrams of Advil, 20 minutes before class, you'll be fine. Yeah, the homework due Monday? Yeah. That box in the top right corner there. So quiz this Wednesday, test next. I give you an old test, I give you a test. Probably won't do it until Wednesday. So most likely I'll do it right before Wednesday. And 3.2 and 3.4 are data driven, but I don't care about that stuff. Don't need it for calculus, that's for sure. All right, here we go. So we're talking now about quadratic. Oh, I'm sorry. You got it? I'll go back. Rafi, sorry. Good? And you can always get up if you need a closer picture. Okay? So quadratic functions. I think you know them, most of them anyway. Ax squared plus bx plus c, right? Haven't we heard of this? Quadratic, right? This is called standard form. I usually can get it to x minus z1 times x minus z2. I can't always get this. Well, actually, I can. This is the fundamental theorem of algebra. Every single quadratic can be factored like this. So this is factored form. F of x equals a times x minus x of v squared plus y sub v is vertex form. Where the vertex is x sub v, y sub v. Most of the time you'll be given standard form, and you'll want to turn it into factored form and vertex form. We've already done vertex form. That's by completing the square, right? Yes? We want to be able to find domain and range. So, right, So this is A is positive. My domain will be everything, right? It goes incredibly wide. Takes a while, but it goes wide, right? And the range is going to be y sub v to infinity, right? The lowest point in the y direction, right? I'm just using the subscript v to say vertex, right? Sometimes the book will use hk, something like that. I like to say x sub v, y sub v. Say again? Oh yeah. Don't let me run you over. Don't let me run you over. Don't let me go too fast. I am your Uber driver. Do not wait till you get home to write me up a bad review. Say he drove too fast. It's called factor form. It's A minus x, the quantity x minus z sub 1, meaning the first zero. And then x minus z sub 2, the second zero. Okay? X sub v, so the z sub 1 meaning first zero, z sub 2 second zero, x sub v meaning the x coordinate of the vertex, y sub v the y coordinate of the vertex. So when A is positive, it opens up, right? When A is negative, it opens down. So A is less than 0 here. What's my domain here? Everything, right? It gets wider and wider, but very slowly. And what's my range here? It's from minus infinity up to y sub v. It's interesting to think about A, B, and C as sliders, right? It's interesting to think about A, B, and C as sliders. So if I go to Desmos, and I would like you to do it at the same time, I will go back to that screen. But I want to think about f of x is ax squared plus bx plus c, and I want to make them all sliders. If I just change c, what's happening to the graph? If I just animate c or change c, what's happening to the graph and y? It's just moving the whole thing up or down, right? And you can see that c value is outside, plus c, right? So plus c means c is 3, move it up 3. C is negative 5, move it up 5. Right? A is interesting too. If I change A is my compression, right? Stretch and compression piece. I'm multiplying the mother function by something on the outside. So it's either going to stretch it real tall or squash it down. So if A is 5, stretch that box up by 5, right? That 1 by 1 box. If A is negative 1, I get the mother function flipped upside down, right? What happens when A is 0? What happens when A is 0? Is it a parabola anymore? No, it's a line because 0 times x squared is gone, so now it's an mx plus b. Well, it's a bx plus c, but, right? All right, and here's the tricky one. What happens when b changes? stuff with the vertex? Okay, everything else is locked. So where is the vertex? So the whole graph is moving where? Yes, left, right, and up and down. You see the shape? Imagine this vertex with wet paint. You see the shape it's creating? What's it creating? Almost. Negative AX squared moving around the reflection upside down the original motor function. Let's see if we can put it in. Y equals negative AX squared plus BX. Oh, but that's moving. Sorry. I don't know how I do it. Here it is. Huh. Let me change that color. So it's moving around that when B is 0 and everything and A is reflected, it's moving around that vertex. So what do you think we should have to find on a quadratic like this? Y-intercept? Yep. X-intercepts? Yep. Vertex? Right? We should be able to find all of those points. Cool. Let's look at a problem. Ready? So we talked about all the theory. Let's get to the problems because that's all I care that you do is the problems. You put all the theory on the paper, your formula sheet. I don't know if you really need it. I think this stuff is kind of a review of things you have already done in the past. But we just probably need a refresher on everything, right? So let's just jump right away to the problems. I got carried away there, sorry. Oh, I'm in the wrong section here. Here we go. Sorry. You might be getting seasick here, I know. Let's just go right here. Graph each function to get me the domain and range. Determine where it's increasing and decreasing. Find me x-intercepts, find me y-intercepts, find me the vertex, etc., etc., etc. We'll do everything here. Let's do 73. Is that one I assigned you? No, right? So this is 3.3 number, 74 I wanted to, yeah, no, 73. So I've got h of x, who cares what letter I call it, right? Minus 4x squared minus 4x minus 1. This is standard form. Yes, open up or down? Open up or down? Down. Leading coefficient negative, it opens down. Leading coefficient positive, it opens up. Let's put it on Desmos. So I have minus 4x minus 4 minus 4x squared minus 4x minus 1, right? Nice, I could see the y-intercept, I could see the vertex pretty easy, but we want to be able to do the manipulation, algebraic manipulation to get it, right? So first things first, let's factor it. So you remember the AC method? A times C is what? Negative 4 times negative 1? You remember this method, AC method? That's 4, right? I want the factors of 4, so 1 and 4 or 2 and 2, but I need them to add to negative 4, so they both must be negative. Is that true? Is it? Did I have this right? I'm sorry. Yeah. So they should, yes. So it looks like negative 2 and 2. Yes, you agree? I need the product to be A times C. I need the sum to be B. Right? AC method, yes? So what I do is I split the middle term here. Right? Double checking that I haven't changed anything. And then I factor by grouping. So what comes out of the first two? It looks like a negative 2x. And what comes out of the second two? I need a sign number to come out of the second two. That looks like a negative 1. And so I get 2x plus 1 again. They match. They better match. If they don't match, I'm in trouble. So I get 2x plus 1 times a negative 2x minus 1, or better yet, negative 2x plus 1 quantity squared. Is that okay with everybody? So I'd like to try and factor it if it can be factored. You're going to learn in chapter 4 that every quadratic can be factored. Some of them are ugly with a factor, but it's all can be factored. That's the fundamental theorem of algebra. Every polynomial can be factored. Sometimes the factors are complex numbers. We're not really dealing with those. Square root of negative 1, we heard that before. Square root of negative 1 is equal to I. Imaginary number I. We're skipping that. This is also vertex form. I don't know if you see it. In this particular case, it's vertex form. You see my compression or reflection is negative 1. What's my x value of my vertex? Negative 1/2. What's the y value of my vertex? Plus 0. Let's put this in vertex form. So this is my factored form. And it won't always be the case that the vertex form and the factored form are the same. So let's put it in vertex form. I have minus 4x squared minus 4x in parentheses minus 1, right? I'm grouping the x squared term and the x term together. And I'm leaving out the constant. What can I factor out from the leading code, from the mother here? What can I factor out from the mother here? Minus 4. So I get what? X squared plus x? I get k. What is k? Is 1, right? Remember the coefficient of x after I factored out that leading coefficient. I get half of k, which is 1/2. And I get that squared, which is 1/4. We doing okay here? I'm going to add the 1/4 inside. And what have I really created there with that 1/4 inside? A -1, so I'm going to add 1 to cancel it. So I get a -4 times x plus half of k, right? So x plus 1/2 quantity squared plus 0. And this really helps me see the vertex, right? So x sub v is -1/2, right? Opposite for interior pieces. And y sub v is 0. X's interiors behave inversely. Interiors behave inversely. So inside here, it looks like I'm adding 1/2, but I'm moving 1/2 to the left. Right? They look a little different, don't they? What I said was vertex form before, vectored form. I could still see my vertex, but in this one, I had to do some work to find the vertex. In this form, the vertex is really right there right away, -1/2. So we like to label things here, right? So we had the vertex of -1/2, comma 0. That happens to also be my x-intercepts, if you didn't notice. 0, -1 is my y-intercept, right? There's really not much else to find there. What's my domain? Everything, right? What's my range? Well, the highest point is 0 in the y direction, right? So -infinity to 0. Inclusive, right? Yes, we okay here? When is it increasing? To -1/2 to the vertex. We never, increasing, decreasing is always open interval. And where is it decreasing? From -1/2 to positive infinity. Right? Increase. So I'm always, when I'm walking on the graph for increasing, decreasing, I'm always going left to right. So when I'm walking here, I'm increasing, right? X is all the way up to -1/2. And when I'm walking here, I'm decreasing. So from -1/2 all the way to infinity. Let's try another. Okay? Is that all right? We ready? Nice. Let's do 61. Wait, did I assign 61? No, good. 61. They won't all factor, okay? So, but they all can be put in vertex form. I'm sorry, that's not true. But we don't really learn how to factor every single one until chapter 4. Okay, so you just got to wait for me there. So number 61, minus 3x squared plus 12x plus 1. So there's my function. Of course, we know it opens down already, right? Do we know the y-intercept already? When x is 0, what's the only thing left? 1. Good. So let's put it into Desmos, because that's how we like to start. I want to, even in calculus, even if you go to UMD for Calc 1, you're not allowed to use a calculator on a quiz or a test, but when you're practicing, you're going to use it. You're going to get to know what the functions look like, so that when you go into class and they give you a function, you can still visualize it. So I like f of x equals negative 3x squared plus 12x minus 1. Did I get that right? Did I remember? Yep. Oh, plus 1. There it is. Opens down. It looks like it factors. How can I see that? How come I can say it looks like it factors? When it factors, I'm finding the zero, right? It looks like it gets an x 0 and an x 4. It looks like it factors. The vertex is pretty clear. What? 6, 13. Right? So what's nice about this, and you're going to learn how to do this for calculus, is you can kind of get the graph just to tell you everything about the function, and then do the algebra to show it's true, right? Do the algebra like it's 1820, but think about it like it's 2022, right? It's not that they didn't have calculators in, they didn't have batteries yet. All right, so what do you want to do first? Factor? Okay, so I got a problem with the factoring because I need factors that I need numbers that multiply to 3, but add to 12. So that's trouble, right? Because all I get is 1 and 3. I'm never going to get to 12 here. So I'm not going to go that way first. So I might be wrong about the factoring, but let's complete the square, okay? So we're going to group our negative 3x squared and our 12x together and leave out the 1. I'm going to factor out what number? Negative 3. And I'm going to be left with x squared minus 4x. And I want to, remember, after I do something, I want to double check it and make sure it's going to work, right? I see k already, yes? Negative 4, yeah? Half of it is negative 2, square it, 4. But I've really subtracted 12 here, so I want to add 12. I'm always going to get x minus half of k squared, and there's my factored version. So where's my vertex? The positive 2, 13, right? Take the opposite inside and be direct on the outside. Brian? Yeah, so if you take a look, I put the 4 inside, right? We took half of k squared. It's always going to be positive. But I really am distributing that a negative 3 to that. So I get an extra negative 12. I have to cancel it. And I kind of want you to do this, right? You get a negative 3x squared. You get a positive 12x. You get a negative 12. You got the positive 1. You got the positive 12. And then these pieces cancel, and you're back to the original. So vertex is 2 comma 13, yes? I think I'm wrong about the factoring, but it 2 comma 13. Nice, there's my vertex. My y-intercept is 0, 1. Okay, that's convincing me that it's not factorable. So 0 comma 1, right? I want to find the x-intercepts. How do I do that? I could factor, couldn't factor. I can use quadratic formula, or I can use my complete the square version. You want a reminder of quadratic formula? So I'm taking f of x equal to 0, and I know x equals negative b plus or minus square root of b squared minus 4ac all over 2a. You have a teacher that sang it to you with Pop Goes the Weasel? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Sorry. So my a value is negative 3, my b value is 12, my c value is 1. You remember doing this before? I want to see if there's a square factor in 156. So definitely divided by 4, right? Yeah. There it is. Kind of ugly. You remember doing quadratic formula before? Yeah. 6 minus plus. Yeah, I divided by the negatives down here, so that became positive and these switched. It's the same. That's just me. We could just write it as 6 plus or minus rad 39 over 3. Yeah, exactly. I mean, I'd like to be able to check everything. So these are my x-intercepts, right? So let's do the positive one first. 6 plus square root of 39. 6 plus square root, SQRT 39, all divided by 3, comma, 0. And there's one of my roots. Right? So we don't want to leave a quiz or a test without checking everything completely. You should walk out of that quiz knowing you got 100% on it. Or walk out of the test knowing you got a 90 and you're like, I'm just not sure about that other one. I couldn't quite check it in time. Right? You should know you have things right. How you feeling? It's nothing new today, right? Nothing new, just a lot of terminology, a lot of little subtleties. You just got to get in there and practice. Get in there and do some problems. But give me the problems I want perfect, right? Do other problems though. Read the book, read the examples, do extra problems. You got all the odd answers. All right, let's do one last section and then get the hell out of here. If you don't have a headache, I don't know what's wrong with you. I have a pounding headache. But I've been teaching math all day, so it's my own fault, of course. All right, last section. Quadratic sine tables. Okay? So nothing to do because we know how to make a sine table. All we got to do is do a couple problems and we're finished. I want to say that if class ends a little bit early and you have questions, I want you to take that time to ask questions, okay? So next class, we're going to have a quiz. You won't be able to ask me questions because other people will be taking a quiz, but you can come before class to ask. So if I end early, you can ask questions. If I end on time, you could ask questions, okay? If you have questions, I want you to ask them. Before class, you can ask questions. I'm moving all my office hours here. So before class from now on, I will be here or right back. Like if I have to go get a drink or, take a smoke. I don't smoke, but you know what I mean, right? All right, 3.5, quadratic inequalities. And what that means is sine tables. Quadratic inequalities, what it means is sine tables. Want to do an easy one first or a tough one? So it says graph each quadratic function, right? Determine if it opens up or down. Find its, I'm reading number 9 here. Find its vertex, its axis of symmetry, the y-intercept, the x-intercepts, domain and range, everything we've just been doing. So let's do one of these. Let's do number 13. It seems like I'm not doing anything new in each section right now, and so, but that's okay. So number 13, we ready? So this is 3.5, number 13. There's nothing to teach here because I've taught you everything, or there's just one little subtle piece. I think the axis of symmetry I didn't talk about yet. So number 13, I got a function negative x squared plus x plus 1/2. I want to get the vertex, the intercepts, the domain, the range, the graph, right? If it can be factored, the roots, all of that, everything. But let's start with complete the square, right? Oh, let's start with the graph. Sorry. So I have minus x squared plus x plus 1/2. Obviously, we can tell it opens down from the leading coefficient being -1, right? Yes, we okay here? Obviously, I can tell the y-intercept at 1/2 because when x is 0, everything else goes away. It doesn't look like my roots are too nice, but we'll do that again with quadratic formula. Let's find the vertex. So I have minus x squared plus x grouped, right? And I'm going to leave the 1/2 out. What am I going to factor out here? The -1. We okay? Good. What's k? K is -1, right? Half of that is -1/2, and if I square it, I get +1/4. Hassan, make sure you tell me if I'm zooming too far. Okay. So I'm adding that 1/4 on the inside. What do I have to add on the outside? Yep, 1/4. Because that 1/4 is actually -1/4, right? That 1/4 on the inside is actually -1/4. So I have to cancel it. I get my vertex form, a times x minus half of k, x plus half of k, quantity squared, and what is that? 3/4, right? So vertex is where? 1/2, 3/4. X equals x of v, so x equals 1/2 is the axis of symmetry. X equals x of v, or x equals minus b over 2a. Have you heard that before? Is the axis of symmetry. Let me plot all of those. Sorry. Where is it? So I had a 0, 1/2 as my y-intercept. Boom. Oops, I got extra parens there, but that's okay. I had 1/2, comma 3/4 as my vertex. Oops. Nice. Oops. I had something else, didn't I? Oh, x equals 1/2 is my axis of symmetry, right? You can see the symmetry around that line. I got to find the roots, the x-intercepts, yeah? Are you ready for it? So I'll do quadratic formula again, okay? I had minus x squared plus x plus 1/2 equal to 0. Is that right? Is that my original? Yep. So I know a is -1, b is 1, c is 1/2. X equals minus b plus or minus the square root of b squared minus 4 times a times c. All over 2a. So I have two roots there, two x-intercepts, right? I have 1 plus square root of 3 all over 2 comma 0, and 1 minus square root of 3 all over 2 comma 0. Is that okay? Yep. Where are you? Yeah, so I'm just saying let's find the x-intercept, right? So I take my original function, set it equal to 0, and using quadratic formula. Yep. So for saying, here's my original function equal to 0, find the coefficient of x squared, find the coefficient of x, find the constant. And then I'm using them in x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yep. And Chris, I'm not picking on you here, but when we're doing things, I'd rather you do them instead of copy, right? If I say find the zeros here, you don't have to copy me. You know how to. You did it in 8th grade or 9th grade, right? You don't have to complete the square, follow me, copy me, completing the square. You did it in 10th grade in Algebra 2 or whatever year you took Algebra 2. I took it in 10th grade and 11th grade. We haven't done much new stuff yet. It's going to start in Chapter 4. Chapter 4 should be brand new. Chapter 5 should be brand new. Chapter 6, 7, and 8 is trig. Some of you have done the easy trig, which is Chapter 6. Not many of you have done the advanced trig, which is Chapter 7. And then Chapter 8 is word problems. I want to plot these two, or at least one of them, right? So I'll do the positive root. So I had 1 plus square root of 3 all over 2, comma 0. And I can see my root is true, right? Of course, on the quiz or test, I'll check both. I'll plot both just to make sure. It asks for a whole bunch of other stuff, but I don't think I have to do it, but you tell me. Open up or down, done. Found the vertex, done. X-intercepts, done. Domain and range, we did a bunch of those already. Increasing, decreasing. You know how to do it. Let's do one more problem and then get the hell out of here, okay? Tell me when we're ready. If you need another minute, it's fine. I want to do the sine table finally. Okay, here we go. Sine table. Where the hell is it? What, am I in the right spot? Oh yeah, here it is. I guess there's only two questions. I must have assigned 19, so I'll do 18. So it's 3.5, number 18. We did all 3 sections in one day. It's a lot. If you don't have a headache, I don't know what's wrong with you, right? Maybe donate your brain to science or something. But just got to get in and practice. So I'm doing x squared plus 6x minus 16 is less than 0. All of these should factor, okay? Which is nice for you to practice your factoring. So how do you see this one factoring? Do you see it right away? I need factors of negative 16 that add to positive 6. X plus 8 and x minus. Good class, x minus 2, right? I see my criticals as what? Negative 8 and positive 2, right? Yes, you with me there? It's when the function equals 0, or when the numerator equals 0, or the denominator equals 0. There's only a numerator in this one. So I want to set up my number line in order with negative 8 and 2, and notice that I can't use those values. Why can't I use those values? Yeah, that's when it's equal to 0, right? And I want it less than 0. I know my domain is from minus infinity to infinity, so I'm going to have column separators with my criticals and row separators with my factors, right? My factors are x plus 8 and x minus 2, and then the product of them is the whole function f of x, right? Eli, that's making more sense now, right? Each row is going to be a factor until I'm done with factors, and then I know I'm multiplying all those factors to get my final sign of my function. Now, what do we know about this thing? Open up or down? It opens up. I already know the answers. Don't I already know it's below 0 between minus 8 and 2? I already know that. And this is, again, the same thing that's going to happen in calculus and calc 2. If you start looking at the graphs, you're going to know what you should get for answers when you start doing the algebra, the calculus, the arithmetic, etc. Okay? So, but we want to test left of negative 8. How about negative 10? In between negative 8 and 2, how about 0? And bigger than 2, how about 100? It doesn't matter where you test. Left of, right of, and in between. So what happens when I plug in the negative 10 to x plus 8? Well, I get minus 2, but all I care about is the negative, right? So negative, negative, positive. Notice that the graph is above ground there, positive. When I plug in 0, I get positive and negative, so when I multiply them, I get negative. That's the piece I want. When I plug in 100, I get positive and positive and positive. So f of x is less than 0. Oh, excuse me. Thank you. When x belongs to the interval from minus 8, from minus 8 to 2, open. Now, I can't teach you anymore. Do you agree? I should not teach you anymore, right? Anybody else agree? I should not teach you anymore. I agree. Well, you should go home and do whatever I would eat dinner and then I would practice. Or unless you have another class. Anybody going to another class tonight? Oh, aren't we lucky? No, I'm done. I've been up since 4:30. It's my own choice. Yeah, walk the dog, etc. Lots. Yep, we're all done.